This is Chem 1B, Experiment 12, Part 4. In this part of the experiment, we're going to compare and contrast voltage and amperage. So I have two cells here that are the same in most ways. So I have a zinc anode and a copper cathode. Here I have 1 molar zinc sulfate with a zinc electrode. Here I have 1 molar copper 2 sulfate with a copper electrode. Same thing here. I have 1 molar zinc ion, 1 molar copper 2 ion. The difference is, for the cell on the left, I have a porous cup whose function is to maintain charge neutrality. And for the cell on the right, I have this cute little salt bridge that serves the same purpose. So the first thing I want to look at is voltage. I'm going to connect my black electrode, my black lead to my anode, and my anode is zinc. Zinc being oxidized is the anodic half reaction. And then my red lead to the cathode in the cathodic department, and the copper 2 is being reduced to copper metal. And we see that the voltage is 1.08 volts, which is pretty close to theoretical for this cell. For this cell, it should be 1.10 volts. Let me see what the voltage is in the other cell. Black lead goes to anode, red lead to cathode. Oh, same voltage. Well, that makes sense because we have the same two half cells making the cell, and the concentrations are the same. So now we're going to look at current. I'm going to use a different function on this Pasco setup. And for the cell on the right, let's see what the amperage is. Oops, let me turn those the other way. I'm changing the connection to the leads because my amperage was negative. I was watching things go backwards. Okay, so here for the cell on the right, I have 1.62 milliamps of current. For the cell on the left, whoa, 73.63 milliamps. That is a lot more. So the question we want to consider is, why? Why is the amperage so much greater for this cell on the left? And to that you might be thinking, what is amperage? Well, amperage has to do with how fast electrons are traveling through the circuit. Not that electrons can go faster or slower, but just how many electrons are moving through the circuit at a given moment. And clearly, electrons, a larger amount of electrons are moving per moment faster through the circuit. So that's one question. Why? Why is the amperage so much greater for this cell on the left? And the other question might be, so these are similar cells, these are batteries. Which one is going to get to equilibrium? Voltage equals 0? Which one's going to get there faster? These are questions that we're going to explore in lab on Wednesday.